All right, let's talk about the Ducati Panigale V4. This thing is an absolute masterpiece of engineering. We're going to pull back the fairings and really get into the science of what makes this bike so incredibly fast, but more importantly, controllable. And that really is the million-dollar question, isn't it? I mean, how on earth do you tame a 214 horsepower race machine and make it something that a regular person can actually ride on the street and, enjoy without being a professional racer? Well, the answer, as you might guess, comes straight from the very top tier of motorcycle racing. Yep, we're talking MotoGP. Ducati basically took all the secret sauce they developed for the track and figured out a way to bottle it up, to put that pro-level performance right into the hands of us mere mortals. Okay, so let's really dive into this first section, taming a MotoGP beast. See, the main goal for the engineers wasn't just, let's make it fast. Honestly, that's kind of the easy part for a company like Ducati. The real challenge, the genius of it, was making all that ferocious power feel intuitive, predictable, and, well, not completely terrifying to ride. And this quote from Ducati themselves just hits the nail on the head. Offering non-professional riders the chance to control the performance of a real racing bike requires full exploitation of current technology. They knew, right from the start, that to pull this off, they'd have to push every single piece of tech to its absolute limit. This was an all-out effort, for sure. So where do you even begin when you're trying to tame a beast like this? Well, you start with its heart, right? The engine. And Ducati's first big move was to create an engine that basically rethinks a fundamental principle of physics in motorcycling. It's pretty wild. And here it is. Just look at that thing, the 1103cc Desmodici Stradale V4. It is an absolute work of art. But its real genius, the secret sauce, isn't just the raw power it kicks out, it's how it helps the bike handle. And that all comes down to one very, very clever component. And that key piece of tech is called a counter-rotating crankshaft. Now, think about this. On pretty much every other street bike you can buy, the crankshaft spins in the same direction as the wheels. It just makes sense. But in the world of MotoGP, they do the exact opposite. And Ducati was like, hey, let's bring that to the street with the Panigale. So why does this even matter? Well, the benefits are huge. By spinning against the wheels, the gyroscopic force from the engine actually works to cancel out some of the inertia from the wheels. So what does that mean for you, the rider? It means the bike is way more agile, it's quicker to turn into a corner, and, this is a big one, it actively resists the bike's urge to wheelie when you get on the gas hard. It's a purely mechanical trick to make the bike feel calmer and way easier to handle. Okay, so the engine is doing its part to help with stability. But what happens when you're hitting, truly insane speeds? At that point, you're not just fighting for grip on the road, you're literally fighting the air itself. The next big problem to solve is how you keep this missile planted on the asphalt. And once again, the solution is pulled straight from the racetrack. Aerodynamic wings. The easiest way to think about these is like upside-down airplane wings. So instead of creating lift to make something fly, they do the opposite. They create downforce, physically smashing the bike down onto the pavement. But do they actually work? Oh yeah. At 270 kilometers per hour, that's about 168 miles per hour. These little wings are generating an extra 30 kilograms of downforce. 30 kilos! That's literally like strapping a big, heavy suitcase to the front of your bike just to hold it down. So why does that 30 kilos of downforce matter so much? Well, for the rider, it's everything. You get way more stability, not just at high speeds in a straight line, but in the corners too. The front wheel feels more planted, more connected. It helps reduce that tendency to wheelie, again, and it even gives you more confidence when you're braking super hard. It's all about adding grip and stability where physics is trying its best to rip it away from you. So how in the world do they figure this stuff out? Well, they use these incredible tools like CFD, that's computational fluid dynamics. It's basically a super powerful computer simulation that lets engineers see the invisible. They can watch how the air flows over every single curve and surface of the bike, and that lets them sculpt the bodywork to get the absolute maximum downforce. All right, let's move on to the bike's brain. We've got the mechanical grip sorted with the engine, and we've got the aerodynamic grip sorted with the wings. But now we need to talk about the invisible electronic safety net, the co-pilot that makes all this superhuman control possible. When you watch a MotoGP race, you see these pro riders doing things that just look impossible, right? They're backing the bike into corners, holding these perfect, smoky slides on the way out. That kind of feel, that level of control, takes an entire lifetime of practice to master. But here's the magic. The electronics on the Panigale V4 are designed to do exactly that, to make the impossible possible for everybody. You have systems like Ducati Slide Control that actually let you feel what it's like to get the bike sliding on corner exit, but with this incredibly sophisticated electronic safety net there, just waiting to catch you if things get a little out of hand. And the whole system is just so versatile. I mean, with the push of a button, you can totally change the bike's personality. You've got Race A for when you're on a track with tons of grip, full power, go for it. Then there's Race B, which gives you all the power but in a more manageable way for, say, a low grip track. Sport mode gives you that full 214 horsepower for the road, and then street mode dials things back a bit, focusing on safety and comfort for your daily ride. So, what happens when you take everything we've just talked about, that backwards spinning engine, the crazy aero, the super smart electronics, and you crank the dial all the way to 11, purely for the race truck? Well, you get something truly special. And this is it, the Panigale V4 SP. That SP stands for Sport Production, which is a legendary name in Ducati's history. It's dressed in this amazing winter test livery, which is inspired by what the race bikes look like during preseason testing. And its one and only purpose in life is to be the ultimate weapon for an amateur rider to take to a track day. Now, here's what's so cool about the SP's philosophy. It's not actually about having the most power or being the most extreme bike. No, the goal here is to be easier to ride fast. In fact, Ducati is pretty open that a regular amateur rider will probably set a faster lap time on this SP than they would on the more powerful, more demanding R version that the pros ride. So how do they pull that off? A huge part of the answer is shedding weight where it matters the most. Just look at this. On the left, you've got the standard forged aluminum wheel from the V4S, which is already super light. But on the right, that's the SP's carbon fiber wheel. It's feather light. And getting rid of that rotating mass means the bike can change direction with so much less effort from the rider. And the list of goodies just keeps going. You've got those carbon wheels, of course. The absolute best brakes Brembo makes, the Stylema R calipers. A numbered, machined steering head so you know it's exclusive. Fully adjustable aluminum foot pegs to dial in your riding position. I mean, every single part on this bike was chosen for one reason, to make it lighter, sharper, and ultimately faster on a racetrack. So, there you have it. That's the journey. We started with this idea of a wild, untamable MotoGP beast. And through some incredibly clever engineering, from a backward-spinning crankshaft to high-tech aerodynamics to a brilliant electronic brain, it's been transformed into this precise, thrilling, and controllable machine for the street and the track. And all this leaves us with one final, pretty mind-bending thought. If engineers can already tame this level of performance and make it genuinely accessible today, it really makes you wonder, what's next? What does the future of user-friendly speed even look like from here?